Hello everyone, today we are going to start the theory that is VSEPR theory, the full of this theory, valence shell electron repulsion. This theory was given by Kunal J. and Kunal Naidoo in 1957. What was the need of this? Can you please give two meanings? The first one, it was used to predict the 3D shape, right? Up till then, तब तक हमको पता नहीं था कि वाटर मॉलिक्यूल क्या थे या फिर अमोनिया NH3 इसका क्या शेप है, हमको शेप नहीं पता उस टाइम. So this theory helped us to determine the shape of the compound, right? As well as we don't know that why the distortion was happening between bond angle. Bond angles के अंदर distortion क्यों हो रहा है? जो लोड पेयर है distortion क्यों करें? क्योंकि bond angle का इमावा होगा ना, या तो angle कम हो जाना या तो angle ज्यादा हो जाना. We'll talk afterwards कि अमोनिया में कैसे bond angle कम हुआ, या वाटर में bond angle क्या रहा, किसी की बात करें, right? Now moving to the postulate of this. Before jumping into the postulate, we should know what the control of valence shell electron pair repulsion is, right? Valence shell electron pair. What do you understand by valence shell? Valence shell, that is the last shell which is ready to donate or accept the electrons, right? That's the valence shell. And what do you understand by electron pair? Then there are two types of electron pair actually. The first one is lone pair and the second one is bonding pair. Now, what do you understand by bonding pair and lone pair? So basically, there are two types of electron pair, lone pair and bonding, right? For ammonia and carbon, so there are how many bonding pairs? The electron which have bonded, it's known as bonding pair, right? It's two electrons, these two electrons, these two electrons. So 6 electrons are bonding electrons, right? One bonding pair represents 2 electrons, okay? And the another one is non-bonding electron. The 2 electrons which are lying here only are lone pair, right? They have not been bonded. So one lone pair also represents 2, right? This theory has given us some of the predictions about the shape according to their bonding pairs, bonding pairs and lone pair, right? That's it. What are the postulates? There were some of the postulates. Which one? The shape was dependent, shape of the molecule, shape of the compound was dependent upon what? Upon the number of bonded and number of non-bonded electrons, right? Total number of valence electrons which the atom has, which I have already told you, like for DNA. Now, moving forward, the second postulate was, we all know this, the electrons which are bonded or non-bonded have a particular electron count, right? If I talk about electron, or also take an example of ammonia. So here also, see, this electron here is negatively charged. We know this very well. Moving forward, this electron is also negatively charged. So what will happen? A repulsion will generate, right? इन दोनों bonds के बीच में क्या होगा? Repulsion होगा. मतलब अगर हम बात करें इसके बीच में this is lone pair और इसके बीच में this is bonding. इनके बीच में क्या होगा? Repulsion होगा. Also, if I talk about water molecule, oxygen, hydrogen, and 2 lone pairs are there. ठीक? तो इनके बीच में भी क्या होगा यहाँ पे? Repulsion होगा. इनके बीच में भी क्या होगा? Repulsion. And obviously, these bonding pairs will also face repulsion, right? So basically, the second point indicates that what would happen if there would be lone pairs and bonding. Okay? So what does this prove है? इससे क्या समझ में आया कि यहाँ पे जो लोन पेयर है और लोन पेयर है इनका आपस में रिलेशन है. साथ साथ में जो बॉन्डिंग पेयर है और लोन पेयर उनका आपस में रिलेशन एंड ऑब्वियसली जो आपका बॉन्डिंग पेयर है और बॉन्डिंग पेयर इनका आपस में रिलेशन. इनके बीच में क्या होने वाला था? कुछ रिपल्शन जनरेट हुई, राइट? इस रिपल्शन के कारण सी इफ आई एम रिपेलिंग यू, अगर मैं आपको रिपेल करूंगी तो आप क्या कोशिश करोगे कि आप मुझसे जितना दूर हो सके उतना दूर जाके आप बैठ जाओ, राइट? इफ आई एम नॉट गुड विथ यू, व्हाट यू विल ट्राई, क्या आप दूर जाके बैठोगे मुझसे? तो वैसा ही इनके साथ हुआ कि लोन पेयर एंड लोन पेयर मतलब नेगेटिव रिपल्शन नेगेटिव चार्ज, राइट? यहाँ बॉन्डिंग पेयर और लोन पेयर क्या कर रहे थे आपस में? ये भी कुछ रिपल्शन फेस किए. And what is bonding pair and bonding pair? These were also facing some kind of repulsion, right? यहाँ पे जो रिपल्शन की टेंडेंसी थी इसकी इन तीनों कंपेयर किया जा रहा है. इनकी जो रिपल्शन की टेंडेंसी इसकी लोन पेयर बॉन्डिंग पेयर एंड बॉन्डिंग पेयर. इनकी जो रिपल्शन की टेंडेंसी थी ये इंक्रीजिंग है, मतलब सबसे ज्यादा रिपल्शन बॉन्डिंग पेयर से था, लोन पेयर then after bond by lone pair and bond by bond. This relation was given by Sidgwick and Goebel in 19. Okay, this idea was the early idea which was given for the pistol group, right? And they took the idea and then after developed the theory. That was it. ठीक, तो हमको ये चीज समझ में आई है. What we have discussed until now, हमने ये डिस्कस किया कि शेप कैसे प्रेडिक्ट हो, हमने ये डिस्कस किया कि रिपल्शन कैसे हो, राइट? रिपल्शन किसके बीच में. With that, we are also going to know that कि ये जो रिपल्शन फेस कर रहे हैं, इस रिपल्शन के कारण मॉलिक्यूल अपना जो शेप है, अपनी ज्योमेट्री है, वो प्रेडिक्ट, right? Now, third point is that it's very important. If I talk about carbon dioxide, right? If I talk about carbon dioxide, what will do? You make this structure and you do carbon dioxide, right? That is it. अब यहाँ पे देखिए ये जो डबल बॉन्ड है, okay? These bonds, the first question is, these bonds are considered as super finger bond. We don't consider this double bond as two bond. Like we won't draw these bond like this. These won't be drawn like this. So we do, and the double bond will be considered as super finger bond. That was okay. So according to these postulates, we have arranged molecule in two types. Like we have arranged molecule first on the basis that they have no molecule. And on the basis they have lone pair. Right? So in accordance to it, we are going to arrange molecules and we are going to predict the shape for it. As well as I'm going to teach you about the hybridization of these molecules. Before we move forward, we should know a very basic concept, that is geometry and shape. So for this, we are going to take a better example. It is ammonia. It is NH3. It has one lone pair and three lone pairs, right? Now I'm going to draw the shape of it. See, in 3D, what happens? These three hydrogen bonds are connected downwards, like this, and this. Okay? Like this. And this is the lone, which is on top, right? About like this. That is it. Now, this structure is known as tetrahedron, and this is the geometry of the thing. And if I remove the lone here, what happens? It becomes the shape of the molecule. The shape is trigonal pyramid. Like, see, it's somewhat like pyramid, and the name is trigonal. That was. So now we're going to continue the topic. This is your tetrahedron, and the shape is this. It is considered without the lone pair. It is your trigonal pyramid. It's like pyramid, right? So yes. Now we are going to divide the topic in two parts, which is first with for which the first one would be without lone pairs, and the second one would be with the lone. See, here I'm going to divide the central metal, the central atom, and for B I'm going to take the bonded atom. The bonded atom would be hydrogen, or oxygen, right? That is. Now let's start with the topic, which is AB2. We know this very well. अगर A ने B के साथ बॉन्ड बनाया हुआ है तो क्या रहेगा? लीनियर बॉन्ड. तो हम A और B को साथ में कंसीडर नहीं करते. What we do? Despite we did AB2, right? कैसे अरेंज होंगे? A with B and B, right? See, the geometry is it is linear in shape, so the geometry is linear. I have told you already this, that geometry is decided with the including the lone pair, and shape is decided without the lone pair, right? So here I have already taken it is linear. For this example, it would be VSEPR, right? See, if we have jumped under this topic, अगर हम अभी तक इस topic तक आ चुके हैं, तो I am considering you are very much known in the electronic configuration, right? You are known with electronic configuration. So let's take an example for BCLT, that is very important. We know this very well. The central atom is B, right? The atomic number of B is 4. The electronic configuration is 1s2 and this, right? That's B. अगर हम बात करें वैलेंस शेल की, तो वैलेंस शेल is second shell. If I draw 2s2, it would be like this, and other orbital of second shell, that is 2p, is vacant. What happens? This is the ground state, and when it gets excited, it gets hybridized and it forms one S. This is your S, and these three are your P, right? And then after this Cl2 jumps forward and donates its electron. They're going to form the covalent bond. Okay. So these two orbitals are involved, which is S and P. So the hybridization would be S, right? That was it. Now moving forward with AB3 molecule. For AB3, the arrangement would be A, B, B, and okay. I have not told you about the bond angle between them. The bond angle is 180. Okay. See, for AB3, ये भी क्या करेंगे? तो arrange होंगे. कैसे arrange होंगे? They would get the maximum distance from each other, right? तो ये कैसे arrange होंगे? 120. Okay. They would get arranged and the shape would be like this. So if you cut it through a plane, अगर एक plane से cut करते हो आप, अगर एक plane से क्या करते हो, उसको cut करते हो, तो ये पूरा पूरा एक ही इस तरह cut हो जाएगा, ठीक है? The half would be upward and the half would be downward, right? एक plane में cut होंगे. Also, that's why this is known as trigonal planar. Planar मतलब क्या? एक ही plane है. The best example is VSEPR Theory. Now, for the hybridization, what we are going to do? Obviously, we are going to take boron, and we are going to do the same thing. I hope that you are going to do it by yourself. For BF3, we are going to take boron, which has 5 electrons in the outer in its shell, and it will be divided into 1s2, 2s2, 2p, right? Valence electrons are this. These are the valence shell electrons. And now 2 electrons over here and 1 electron, right? What happens? This is a ground state. And if I talk about excited state, what happens? These get mixed, hybridized, energy gets equal and has 3 electrons. Okay? So it's going to pair up with 3F, that is fluorine, like this. So S and 2P are getting involved. Okay? So the hybridization is sp2. Nice. Now, if we talk about the third structure, that is AB4. Okay. So how this molecule gets involved? It forms these pairs. And this is known as tetrahedron, which I have told you earlier about ammonia, right? Tetrahedron. The carbon basically forms these kind of structure. It has CH. The best example for it is methane, right? Also ammonium. For the hybridization, what we are going to do? For carbon, we know it has 6 electrons in its shell. Also 1s2, 2s2, and 2p2 is the electron configuration for it. We know that the valence shell has 4 electrons like this. When these get hybridized, it forms orbitals like this. In the ground state, possibility is this, and the excited state. So it's going to form bond with H4, 4 hydrogens, 1, 2, 3, and 4. right? 1s and 3p are getting involved. We are going to write S3p, right? It is the hydrogen. Moving forward for AB5 type, see AB5 is there. Can you predict the shape of the molecule or the symmetry of the molecule? See, three molecules would be like this in the same tree, and two would be forming a pyramid over like this. Okay, so it would be like A bonded with B, bonded with B, bonded with B. A whole triangle would be here, and one on top, one and one, like this. This is known as trigonal pyramid, bipyramidal, or simply TDP. It's what I call it. Right? It is TDP. And the basic example for it would be VSEPR. Right? For the hybridization, what we are going to do? Same thing which we did with BF3 and CH4. Phosphorus, we know this very well, is 15, has 15 electron, and the electronic configuration for it would be neon 10, 3s2, 3p3, 3 to 5, right? That's it. Okay. If we draw the electronic configuration, see 1, 2, 3, 4, 5. That's it. 3s has 2 electrons and 3p has 3 electrons. 3d is vacant, right? It has to be vacant. This is the ground state. If we are going to get the excited cell from it, this is the hybrid state. One is CP and one D gets involved. However, come to note it one D is going to involve. This electron is going to jump where? This electron is going to came there. 1, 2, 3, 4, 5. 5 electrons are filled by phosphorus already, and here comes another 5 electrons of chlorine. So S, P, 3, and D. These 5 orbitals are getting involved. Hence, the hybridization would be sp3. Moving forward to the last one, which is AB6. See, this is very well known. If I talk about AB6, assume the structure like this, right? There would be four atoms that will be bonded in a single plane, and two will be in the top, like that. Okay, 4 atoms in a single plane, 2 at the top. This structure is known as octahedral. So the bonding it could form bond there. B, and okay, this begins to add, and these two B's would be the top and bottom, right? This is known as octahedral. The geometry is known. The perfect example would be SF6. So for sulfur, we are going to predict the hybridization. For sulfur, as we know, it has 16 electrons in its shell. 1s2, 2s2, 2p6, 3h2, and 3p4. This is the electronic configuration for it. The last, the last shell is valence shell. Here we are going to predict again the hybridization. See 1, 2, 3, 4, 5, and 6. Now 6 electrons are filled here. 3s2, 3p4, and obviously 3d is vacant. Right? What's going to happen? This electron will jump forward. Right? They will form and hybrid orbital like this. 1s, 3p, and 2d would get involved. Another would be lying there. So 1, 2, 3, 4, 5, 6. 6 electrons have been fixed here. After this, sulfur would come and would form a bond with these electrons. So basically, 1s, 3p, and 2d are getting involved. The hybridization would be sp3d. Right? These are the structural geometry. Now, let's not skip the topic about the bond angle. See, in AB2 molecule, A and B have 180 degree bond angle. For 83, these two B's, and these two B's have the same 120 degree angle. Here, this one has 109.5 degree angle. After this B AB5. In these B, it is 120 degree, and this B with respect to these plane of B forms 90 degree. Also, these two B's come to right? Moving forward here, these four B's, you know this very well, that in a triangle, in a rectangle, what happens if I arrange these four molecules? They are going to be arranged in a proper line. So they will be perpendicular to each other, right? Same thing happens here also. These are perpendicular to each other, these four B's, and they form 90 degree. As well as this B on top and this B on bottom, they also are perpendicular to both. So these are also going to form 90 degree. And as well, this top one and this bottom one are going to form 180 degree. Right? That's it. So that's it for the first part. Now we are going to move forward for the lone pair part.